What's up, everyone? Today we're talking about geometric sequences and series, so let's just get into some vocab. A sequence is called geometric if you multiply by the same amount each time, and that piece that you're multiplying by is called the common ratio, and it is denoted by the letter R. That common ratio can be positive, it can be negative, it can be an integer, it can be a fraction or decimal. It all depends on the circumstances. So you'll see any one of those four things happening. So some formulas, again, taken right out of your formula booklet, so you don't have to worry about memorizing them at all. I have already put in the four things that we've already seen before. And then the last thing that we haven't officially talked about yet is that common ratio. So the R in all of those formulas is just your common ratio. And remember, that common ratio can be positive or negative, a whole number or a fraction or decimal. Lots of options there. So getting into our first example, we have three different problems that for each of them, we are going to find or identify the first term, the common ratio, and then the 10th term. So for letter A, and identifying our first term, pretty easy. It's right there in front of us. My first term is 2, and I should probably say u sub 1 equals 2. Finding our common ratio. In order to find your common ratio, if you can't automatically tell, some are easier to tell than others, you can always take the second term divided by the first term, and that'll give you your common ratio. I would make sure, especially if they're asking, is this a geometric sequence? I would make sure you do that for each consecutive term. So I could do it with the third divided by the second, the fourth divided by the third, just to make sure it's the same common ratio, or it is a common ratio. Part 3, using that general formula, we're finding the 10th term. So I'll sub in 10 for n. My first term I just identified was 2. My common ratio I just identified was 3. And again, subbing in 10 for n. And just like many other things we've done, it's up to you how you evaluate this. You can do it in your head if you're good with your powers of 3, or you can type the whole thing into your calculator. And either way, you should get 39,366. Part B, our first term again right there, we can see that it's -3. Finding my common ratio, I can take the second term divided by the first term. And I can see that my common ratio then is -2. And then finding the 10th term, I'm not going to keep writing the same formula because we're using this exact same one. So I'm just going to sub in what I know. So I have my n equaling 10 still. My first term this time is -3. My common ratio this time is -2, but still being raised to the 10 minus 1. And I get that my 10th term is 1,536. Finally, part C, my first term equaling 16. My common ratio, if I keep up the same thing, dividing second term by first term, I get either, and this is your choice, either 1/2 or 0.5. Doesn't matter which way you leave it, fraction or decimal form. If it's a fraction like this, or a decimal, I should say, like this, where it is a terminating decimal, it's fine either way. If it's a fraction like 1/3 or 2/3 or 1/6, where it's a repeating decimal or just a non-terminating decimal, I would say leave it in fraction form just so that you get a more exact answer. But like I said, this one doesn't matter. 1/2, 0.5, they're both easy to work with. So putting in my pieces to my general term formula, and I get either, depending on, again, fraction or decimal, I either get 1/32 or 0.03125. You could even say, if you're trying to do always 3 sig figs, you could even say your answer is 0.0313, rounded up a little bit at the end. So part C, we got lots of different options. All right, in our next example, we have a geometric sequence with all positive terms. I feel like that's important, so I'm going to go ahead and underline that. It has a third term of 8 and a fifth term of 128. So I'm going to rewrite those just using our U sub blank, just so that it makes a little more sense maybe. So I have U sub 3, meaning my third term equaling 8, and my fifth term U sub 5 equaling 128. We are first asked to find the common ratio in the first term. So if you remember the exit ticket from the arithmetic sequences in series, we did something similar where we wrote two equations in U1 and D and then solved that system to solve for the common difference in the first term. And you can still do it that way, but I also wanted to show you a different way in case that way didn't really vibe with you. So as an alternative, you could also say, in order to get from my third term to my fifth term, I'd have to multiply that 8 by r twice, once to get to term 4, and then once to get to that fifth term of 128. So I'm going to set up a little equation that just kind of shows that. So if I want to get from my third term, which is 8, to my fifth term, which is 128, I'd have to multiply 8 by r twice. Usually we don't write it like that. So instead, I'm going to write it as 8r squared equals 128. So now you just have this formula that once you solve for r, you'll have your common ratio, and then we'll talk about how to get your first term. All right, so I found r to be 4, and remember it said that all terms are positive here, so that's why instead of saying plus or minus 4, I just left it as regular 4, just a positive 4, because everything has to be positive. If it didn't say that, then I would want to keep in the plus or minus because I don't know which one they're looking for. It could be both. So just keep that in mind. To find your first term, again, a couple different options. Because they gave me the third term, which is pretty close to my first term, I could go backwards in the sense that instead of multiplying by 4 to move forward in my sequence, I can divide by 4 to move backwards in my sequence. So a little bit of mental math, 8 divided by 4 to get my second term would get me 2. 2 divided by 4 to get me all the way to my first term would get me 1/2. If they gave you a term in the sequence that it was going to be too much to keep dividing, you could also use your general term formula, sub in either of the terms they gave you, and then solve for u sub 1. Letter B asks us to find the 8th term, so again, using that same formula, subbing in what we know. So again, evaluating that either all at once in your calculator, or if you'd rather do step by step, either way, you get that the 8th term is 8,192. For your sum of the first 8 terms, if you notice there were 2 different sum formulas, it absolutely does not matter which one. They just switch the 1 minus r and r to the nth, or keep it as r to the nth minus 1. It doesn't matter at all which one it is. There's no preference at all. It's just both are common, so that's why both are in there. So choose one, plug in what you know, and then evaluate. All right, so I chose the one that starts with the 1. Again, it doesn't matter. I don't even know why I picked that one, but I subbed in everything I knew, and when I plug it into my calculator and evaluate, I get something along the lines of 4,681.07. So a lot of the times with your geometric series, when your R value or your common ratio is a decimal or a fraction, your summations are going to be some kind of crazy decimals. So again, remember IB likes 3 sig figs when you have to round. So we'll round this to 4,680 as our answer. Final example, good old word problem. When Kenzo starts Bright Academy, the school fees are 2,500,000 Japanese yen. The fees increase at 2% each year, and he attends the school for a total of 6 years. So first has to write down just the common ratio. So first of all, think about anytime you sub in, anytime you sub in a percent to a formula, you usually change it to a decimal first. So 2% as a decimal is 0.02. anytime you're talking about increasing by a certain amount or decreasing by a certain amount, when that amount is a percentage, you do have to play with it a little bit, or you have to do something to it before you sub it into your formula. If you want it to increase, like we do here, we're going to add 1 to it. And what that does is it starts with your, whatever you started with, right, the 100%, and it'll add the 2% every time. When it's something decreases, you're going to start with your 100% and you're going to subtract the percentage that they're asking you to. So if this instead said the fees decrease by 2% every year, I would do 1 minus the 0.02. So increase, we do 1 plus, decrease, we do 1 minus, whatever that percentage is. So for our example, we're looking at a common ratio of 1.02. Part B wants us to calculate the school fees in year 6. So again, using the same formula we've been using all day and subbing in what I know. I know now that I'm looking at year 6, so N is 6. My first term was the initial amount, so 2.5 million yen, or 2,500,000. The common ratio I just found was 1.02, and my N is 6. And doing some calculator math, I get that the 6th term, or in the 6th year, they are paying 2,760,202 yen and 1 cent. I'm not exactly sure how Japanese yen work in terms of dollars and cents. I'm thinking about dollars and cents, so I'm keeping it as the hundredths place, but you could always, remember 3 significant figures, you could always leave it as 2,760,000 Japanese yen, because that's correct to 3 significant figures. So I'm going to go with that one. Finally, in part C, we're looking at the total fees paid for the 6 years. So total meaning some, not just in that 6th year, but through all 6 years, how much did they pay? So we'll use that sum formula. Again, it doesn't matter which one you use, but sub in what you know, and then work some calculator magic, and you get that they paid a total of 15,770,302.41 Japanese yen. And again, to 3 significant figures, I would leave this as 15,800,000 Japanese yen.